SpaceX just did the impossible, and almost nobody noticed. After two devastating failures on September 18th to 19th, Ship 38 seemed finished. But then SpaceX pulled off a flawless, full-duration, static fire with zero anomalies. This isn't just a comeback, it's the final green light for Flight 11. Here's the shocking truth. We're now witnessing either humanity's Mars breakthrough or the biggest space gamble in history. 76 meganewtons of thrust, 230 tons per engine, perfection when it mattered most. The question isn't if Flight 11 launches, it's whether we're ready for what comes next. Let's dive right in. Picture this. September 22nd, 6:47 a.m. at Starbase. The sun barely breaking the horizon when suddenly the ground starts shaking. Not from an earthquake, from 230 tons of controlled fury igniting beneath Ship 38. What happened next wasn't just another test. It was the turning point that separated SpaceX from every other space company on Earth. But to understand why this moment matters so much, we need to go back to the two failures that almost destroyed everything. September 18th should have been SpaceX's triumph. Engineers had spent weeks preparing Ship 38, checking every fuel line, verifying every system. The countdown began smoothly until the critical moment. Then nothing. Complete scrub. The quick disconnect system, designed to fuel the massive rocket, simply refused to cooperate. The next day brought even more frustration. September 19th started perfectly. Cryogenic propellants began flowing, creating those telltale frost lines on the rocket's hull that signal everything is working correctly. Pressure gauges climbed exactly as planned. Then, just when success seemed certain, another failure struck. Technical issues with the QD plate brought everything crashing down. Most aerospace companies would take weeks to recover from such setbacks. SpaceX did something different, something that reveals exactly why they dominate this industry. Within hours of the September 19th failure, SpaceX had already scheduled new attempts for September 22nd and 23rd, while their competitors would still be organizing failure review meetings. Musk's team was implementing fixes in real time. This isn't just speed, it's a completely different philosophy. Traditional aerospace treats every problem as a potential disaster requiring months of analysis. SpaceX treats problems as data points to be solved immediately. When you're burning $3 million per day in operational costs, this approach isn't just smart, it's survival. The QD plate issues that stopped September 19th, resolved overnight through rapid hardware modifications, fuel line complications, eliminated with precision engineering adjustments. By September 21st, Ship 38 was ready to make history. September 22nd arrived with ideal conditions at Starbase. Clear skies, minimal wind, perfect atmospheric pressure. But the real action was happening at ground level, where months of preparation were about to pay off in spectacular fashion. At exactly 6:47 a.m., the water deluge system activated. Torrents of protective spray erupted from the steel plate beneath Ship 38, creating a man-made geyser of steam and mist. This wasn't just for show. Those water systems protect critical infrastructure from temperatures that can melt steel in seconds. Then came ignition. 39 Raptor engines, each one capable of generating 500,000 pounds of thrust, fired simultaneously. The sound didn't just reach your ears, it penetrated your chest, shook buildings miles away, and announced to the world that SpaceX had achieved something extraordinary. But here's what made this test different from all the others. This was a full-duration burn designed to replicate exactly what Ship 38 will experience during Flight 11's crucial ascent phase. Let's examine the raw data because these numbers tell a story that changes everything about space exploration. Ship 38's static fire generated 76 meganewtons of thrust. That's equivalent to 88 Boeing 747 engines running at maximum power, all at the same time. The thermal output reached over 3,000 degrees Celsius, hot enough to melt copper instantly. To put this in perspective, NASA's Space Launch System, currently America's most powerful rocket, maxes out at 39.1 meganewtons. SpaceX just demonstrated nearly double that power. More importantly, SpaceX's official statement included a phrase that aerospace engineers immediately recognized as game-changing. Performance remains stable throughout. This isn't marketing language. It's confirmation that Raptor engines can maintain consistent thrust levels during extended burns, something previous tests struggled to achieve. What does this mean for actual missions? Starship can now confidently attempt orbital maneuvers, deep space burns, and Mars landing sequences that require sustained, predictable power over long periods. The technical breakthrough is complete. While Ship 38 dominated headlines, the real revolution might be happening with Booster 15. This isn't a brand new vehicle. It's a proven workhorse using engines that successfully flew on Flight 8. SpaceX is attempting something no company has ever achieved, reusing their most powerful hardware at industrial scale. The economics are staggering. Traditional rockets cost $500 million per launch and get thrown away after one use. If SpaceX can successfully reuse Booster 15, they're looking at launch costs under $10 million per flight. That's not improvement. That's complete market transformation. On September 20th, we saw this strategy in action. B-15's hot staging ring was transported from the Star Factory to Megabay 1 with surgical precision. Within hours, cranes lifted the massive component into position. By evening, installation was complete. Operational tempo that would be impossible for any traditional aerospace company. This timeline reveals SpaceX's supreme confidence in their refurbishment processes. They're literally betting their entire program on previously flown engines. It's either calculated genius or unprecedented risk, and we're about to find out which. Current projections suggest Ship 38 could roll out to the launch pad by month's end, with Booster 15 following shortly after. If accurate, this represents a turnaround time faster than most airlines service their aircraft between flights. SpaceX's previous record stood at 37 days between Flight 5 and Flight 6. Breaking that benchmark would send shockwaves through the aerospace industry and prove that SpaceX has achieved something approaching airline-like operations with rockets designed to carry humans to Mars. This pace matters more than most people realize. NASA's entire Artemis lunar program depends on Starship's success. Every day of delay pushes America's return to the moon further into the future. But if SpaceX maintains this operational tempo, we could see lunar missions happening years ahead of original schedules. Meanwhile, competitors are struggling to keep up. Blue Origin has remained conspicuously silent about their progress. ULA has postponed their own engine tests indefinitely. Even established players like Arianespace are suddenly announcing revolutionary changes to their roadmaps. When your competitor demonstrates twice your maximum thrust while discussing monthly launch schedules, every conversation becomes about survival. Every SpaceX development ultimately serves one goal: making humanity a multi-planetary species. Ship 38's flawless static fire just moved that timeline significantly forward, and the implications are staggering. Current projections suggest uncrewed Mars missions could begin as early as 2026, with crewed flights following by 2028. But here's the critical factor. Mars transfer windows only occur every 26 months due to planetary alignment. Miss the 2026 opportunity, and humanity waits until 2028. Miss that window, and we're looking at 2030 or beyond. The stakes extend far beyond exploration. China has announced their own Mars ambitions with targeted landings in the early 2030s. If SpaceX executes their timeline successfully, America maintains space exploration leadership for the next generation. If they stumble, we might watch Chinese astronauts plant the first human footprints on another planet. Ship 38's success just kept the 2026 timeline alive, and with it, America's chance to lead humanity's expansion into the solar system. While everyone focuses on Mars exploration, the real revolution is economic. Starship's cargo capacity, 100 to 150 tons to low Earth orbit, exceeds every other operational rocket combined. At projected launch costs under $10 million per flight, satellite deployment becomes affordable for countries, universities, and private companies previously excluded from space access. Consider what this means. Every telecommunications company, weather monitoring service, in GPS provider suddenly gains access to launches costing 95% less than current options. The entire satellite industry is about to experience explosive growth, and SpaceX controls the gateway. This economic transformation explains why competitors are panicking. It's not just about rockets anymore. It's about controlling access to the ultimate high ground of human civilization. Flight 11 isn't just another test flight. It's SpaceX's declaration that they've graduated from experimental rocketry to operational capability. Success would demonstrate Starship's readiness for real missions, deploying massive Starlink constellations, delivering cargo to the International Space Station, and beginning NASA's lunar program in earnest. But the consequences of failure would be devastating. A Flight 11 explosion would trigger months of investigations, regulatory reviews, and program delays. NASA might reconsider their Artemis partnership. Commercial customers would flee to competitors. The entire SpaceX narrative of rapid iteration and acceptable risk would face its ultimate test when the world is watching. One crucial factor remains completely outside SpaceX's control: federal regulatory approval. The FAA has historically taken months to approve flight licenses, even when SpaceX hardware sits ready weeks in advance. Flight 11's timeline depends entirely on bureaucratic processes that move at government speed, not SpaceX velocity. Recent reports suggest the FAA faces mounting pressure to accelerate approvals due to international competition concerns. If China achieves major space milestones, while American rockets remain grounded by paperwork, congressional hearings become inevitable. As Ship 38 prepares for its journey back to the production facility, every SpaceX engineer understands they're working on humanity's next giant leap. The successful static fire proved their hardware works flawlessly. Now comes the ultimate question: can they execute perfectly when billions of people are watching and America's space leadership hangs in the balance? This is exactly why SpaceX's flawless static fire changes everything. That perfect burn didn't just prove Starship works. It proved Mars missions are now economically possible. What this means is clear. We're no longer asking if humans will reach Mars, but when America gets there first. The bigger picture is undeniable. While competitors struggle with basic reusability, SpaceX just validated the system that makes interplanetary travel affordable. Flight 11 isn't just another test. It's America's ticket to lead the next chapter of human exploration. And this is just the beginning. With Starship proven, NASA's moon missions accelerate, commercial space stations become reality, and Mars colonization moves from dreams to detailed planning. The next year will redefine humanity's future in space. Here's my question for you. Can China's Mars program catch up to SpaceX's timeline? Or has Musk already secured America's victory in the space race? Tell me your prediction in the comments below. If this breakdown helped you understand what's really happening in space, hit that like button right now. This is Space Hub, where we decode the space developments that actually matter for your future. Subscribe and ring the notification bell so you never miss the moment when history gets made. Share this with anyone who needs to know why SpaceX just changed everything. The space age isn't coming. It arrived on September 22nd, and we're covering every breakthrough as it happens. Elon Musk just shocked NASA with a plan that could change space forever. SpaceX officially revealed they want to launch 44 Starships per year from Kennedy Space Center, turning America's most iconic launch site into an airport for rockets. This unprecedented move has NASA scrambling to redesign 60 years of operations. The shocking reality: commercial flights face 2-hour delays, air traffic networks need complete rerouting, and the FAA already released hazard zone maps showing massive disruptions. SpaceX spent years conducting secret blast testing and sharing classified safety data with federal agencies. Industry experts are split. Revolutionary breakthrough or operational nightmare? Let's dive right in. So what exactly did SpaceX reveal that has NASA scrambling? The answer lies in a 50-page document that reads like science fiction, but is backed by cold, hard data. From moon launches to airport operations, picture Kennedy Space Center in March 2025. Astronauts from the Fram-2 mission are watching a Falcon 9 rocket streak across the sky while heading to their own launch. This wasn't just a cool moment. It was SpaceX showing the world their vision of the future. That vision? Transform America's most iconic launch site into an airport for rockets. Multiple launches per day, multiple companies, rockets launching when ready, not when bureaucracy allows. It sounds impossible until you realize SpaceX has already proven the concept works. Their Falcon 9 rockets now launch every 2 days on average from Florida. That's over 100 launches per year from a single location. Something experts once called impossible. But Falcon 9 is small compared to what's coming next. This is where the story gets complicated. Starship isn't just bigger than Falcon 9. It's in a completely different category. Standing 400 feet tall when stacked, it's the largest rocket ever built. And SpaceX wants to launch 44 of them per year from Florida. The math is staggering. Each Starship launch creates safety zones that could shut down commercial aviation for hours. Florida handles over 1,000 flights daily through its airspace. One Starship launch could delay hundreds of flights, cancel connections, and cost airlines millions. The FAA has already released preliminary hazard zone maps that show the scope of the problem. Aircraft would need to reroute hundreds of miles around each launch. Major airports could face ground stops. The disruption would cascade across the entire eastern United States. So how does SpaceX plan to solve this seemingly impossible puzzle? The answer took them years of secret research to develop. Here's what most people don't understand about rocket safety zones. For decades, government agencies have been guessing. They use conservative mathematical models because they don't have real-world data on what happens when modern rockets explode. Most rockets historically used hydrogen or RP-1 fuel. Starship runs on liquid oxygen and methane. These fuels behave completely differently when things go wrong, but nobody had the data to prove it, until SpaceX decided to create that data themselves. For years, SpaceX has been conducting blast tests at their McGregor, Texas facility. They deliberately explode rocket components, measure the results, and feed the data into sophisticated computer models.